we are going to now talk about how slope that you learned about in the last lesson combines with ideas from geometry to become important. So slope is mostly an algebraic concept. We talked about the rise over run, or change in y over change in x, that subtraction of the y values divided by the subtraction of the x values as being our slope. So why is this important in geometry? So the reason why slope becomes important in geometry is then we can compare lines with their slope. And so we're going to compare two different types of special lines. The first kind is parallel. Parallel lines are going to have the same or equal slopes. So if slope is rise over run, sorry, I just looked up at that and that is terrible handwriting. I'm really sorry about that. Okay, sorry. Parallel, if slope is rise over run, and in geometry, we think of parallel as being non-intersecting. So we can think about two lines as they're traveling along. They need to be rising and running at the same rate. Otherwise, if this one's rising faster, they're going to end up crashing into each other, right? So they have to be rising and running at the same rate to remain parallel, to remain the same distance apart from each other and non-intersecting. So parallel lines will have equal or the same slopes. Our other type of special line, what do you think it is? You probably guess it. You're right. There's my Dora. Okay, so you're right. It's perpendicular. Perpendicular lines are lines in geometry that we say intersect at a right angle. So what is one thing that you would think would have to be true if two lines are going to intersect, try to get on the camera again, there we go, at a right angle? Well, what do you think? In the last lesson, we talked about different kinds of slopes, not just rise over run, but there were two different kinds of slopes, and we said positive and negative. So one of them is going to have a positive slope. Oops, that's the wrong for how it's showing for you, I think. I don't know, it might get flipped. One of them is going to have a positive slope, and one of them has to have a negative slope. So that's one thing that will have to be true about perpendicular lines, is they're going to have opposite. So when we say opposite, what we mean by that is positive and negative. You have to have one positive slope and one negative slope. But that's not enough. You can't just take any positive and negative slope and say that they're going to intersect at a right angle like perpendicular lines do. The other thing that's going to happen is we're going to have one line's rise become the other line's run. So what we're going to do is change the rise over run out for a run over rise. So if we're thinking rise over run switches to run over rise, what do we call that in math when we take a fraction and we take it and go whoop, like that? You're right. We call it a reciprocal. So opposite and reciprocal. Y'all are like, Mrs. Straters, I can't even spell reciprocal. It's because I'm trying to talk. Reciprocal. Yeah, I am losing my mind. You're right. As I am, doing Dora impressions for you now, I miss being able to ask questions and have you answer them and interact. So I'm just going to pretend like that's still happening, and I'm going to do Dora for you. So I'll keep asking you questions and then just pretending like you always get them right. Maybe sometimes I'll pretend like you get them wrong. I don't know. Reciprocal means flipping over. Okay, so two things have to be true for lines to be perpendicular. The slopes have to be opposite, a positive and a negative, and reciprocal. They have to be flipped over fractions of one another. Okay, so let's look at some examples. All right, first example, let's say that I have points located at -3, 5, and 7, 15. Those points make one line, okay? And my second line has points at 2, -6, and 4, -4. Okay, so those first 2 points, connect the dots, make one line. Second 2 points, connect the dots, make another line. What do we know about those two lines? Are they going to be parallel Are they going to be perpendicular or neither, right? Because lines don't have to be parallel or perpendicular. They can just be lines that intersect at some angle that's not a right angle. So what kind of lines will these be? To decide, we're going to compare their slopes. So we're going to find the slope of these first 2 points. So as we learned in the last lesson, I'm going to name my points, point number 1 and point number 2. Okay, and now we're going to find our slope, which we learned in the last lesson is y2 minus y1 over x2 minus x1. And like we talked about in the last lesson, we want to be extra careful with those minus and negatives. So I got 10 over minus a negative really makes plus. So I've got 10 over 10, which is 1. Okay, so the slope of that first line is 1. That's great. Good for it. That doesn't tell us yet our answer, parallel or perpendicular. Now we have to go look at that other line. So now we're going to do the same thing with the other line. So in our other line, call that point number 1, call that point number 2, and find our slope. So slope is y2 minus y1, careful of the double negative there, and x2 minus x1. So double negative on top, we're really adding then. Negative 4 plus 6 makes positive 2 over positive 2, which is 1. Now we can compare those slopes and say, are these two lines going to be parallel, perpendicular, or neither? To be parallel, we're looking for equal or the same. Are those two exactly equal to each other? Positive 1, positive 1. Yes, they are exactly equal to each other. So these two lines are going to be parallel, or we can use our geometry symbol for parallel as well. Let's look at a second example with points here. So my first line is going to go from 2, 8 to negative 3, 5. And my second line is going to go from 1, 8 to 4, 3. Okay, now we want to decide, are these two lines going to be parallel, perpendicular, or neither? All right, so once again, first line, I'm going to name those point number 1, point number 2, and I'm going to find my slope by taking y2 minus y1 over x2 minus x1. No double negatives on this one, but still need to be careful about adding and subtracting. So 5 minus 8 makes negative 3, and negative 3 minus 2 makes negative 5. That fraction cannot be reduced, but they both have negatives, so we'll say negative or negative is positive. So that first line has a slope of positive 3/5. So it's a rising line, rise of 3, run of 5. Second line, for comparison, name it point number 1, point number 2, and our slope is at y2 minus y1 over x2 minus x1. So 3 minus 8 makes negative 5. 4 minus 1 makes 3. So now we want to compare these. For parallel lines, we need to have equal or exactly the same slopes. 3/5, negative 5/3. Those are not exactly the same, so they're not parallel lines. Perpendicular needs to be opposite. One of them positive, one of them negative. Yes, that works out. The first one's positive, the second one's negative. And reciprocal. We need to take that fraction and flip it upside down. 3 over 5, 5 over 3. Yes, that works out as well. So because both of those things are true, opposite and reciprocal, these lines are going to be perpendicular. Or we can use our geometry symbol of that upside down T. Now, if only one of those was true, if it's only a reciprocal or it's only a positive negative, that's not good enough. Then we would just say neither. It has to be both, opposite and reciprocal. Okay? All right, well, let's also look at this idea on graph. So on a graph, let's make, whoop, having trouble tracing there. Okay, make some axes, and then I'm gonna make a line. Sorry, I'm like going perfectionist here, and that was taking a lot longer than it should have. Okay, and then I'm gonna make a second line. And now we want to know, how are these two lines related? Are they parallel? Are they perpendicular? Or neither? All right, well, they don't look parallel, right? That we can just eliminate that choice right away. Those are not parallel lines. Clearly, they intersect each other. Do they intersect at each other at a right angle? Looks like it, right? And that's a good enough answer in geometry, right? No. Looks like it is never a good enough answer. So, how can we tell if these are actually perpendicular, if they actually intersect at a right angle? Slope. Slope is the answer. So what we need to do is, like we did in the last lesson, find two clearly crossing points. And that's why I was trying to take a really long time to actually make it clearly crossing the way that I wanted it to. So here's two clearly crossing points. So we're going to look at our slope, rise over run, 2 over 1. So this line has a slope of rise over run, 2 over 1. Well, what about the other line? The other line, these are the 2 points that I intended to be clearly crossing, and then I went a little bit faster on that one, so it's not quite as perfect, but we'll go with it. This is a falling line, so fall over run. So this line slope is -1/3. So we already said they're not parallel. Are they perpendicular? Are they opposite? Yes, positive and negative. They are opposite. Are they reciprocal? No, 2 and 3. So these lines, these are neither. So it looks like it is not a good enough answer for perpendicular. It's also not a good enough answer for parallel, because maybe they're really close to parallel but just slightly off, and they're going to end up crashing somewhere way out there. So make sure that you check those slopes. Okay, check the slopes. Make sure for parallel, we expect the slopes to be exactly equal. For perpendicular, we need opposite and reciprocal. Ask me whatever questions you have. I am happy to help, and I'll see you again soon. Have a great weekend.